For our next motion example, we have two runners, one averaging 8 miles per hour and the other 6 miles per hour, start at the same place and run along the same trail. It should be fairly obvious at this point that they're starting in the same place, running along the same trail, that they will not finish in the same amount of time. The person who's running 8 miles an hour is running faster than the person who's running 6 miles an hour. There's no way that they could finish at the same time. That being said, we have this extra caveat right here. The slower runner arrives at the end of the trail a half an hour after the faster runner. And how far did each person run? Now, we know because they run the same trail that is the same distance, that's going to be our variable. That's the thing we don't know. Of course, we're being asked for that, but the length of the trail is that thing that we don't know. That's going to go for both of the runners in the position of the X. Runner number 1 is traveling that distance, and he's going 8 miles an hour. That's his distance over rate. Runner number 2 is also traveling that distance, but he is only going 6 miles an hour. A slower rate, he shouldn't finish in the same time. It would be logically impossible for the two of these people to finish at the exact same time unless there was some kind of head start involved. So we need to adjust this equation. We can't just say they're equal to each other because they're not going to be. We need to mix in the fact that one runner arrives at the end of the trail a half an hour after the faster runner. Now, because our unit of time is hours for both of the rates, we can assume that any number that comes in that's representing time is already in hours. So here's the time of the first runner, and here's the time of the second runner. But the problem with the time of the second runner is that the second runner runs for an extra half an hour. So once the first person is done, there's an extra half an hour that goes by for the second person to finish. In order to show that, we want to put into this equation a representation of that half an hour extra that the second person had to run. Now, you'd think that that needed to be a plus sign and not a minus sign. You're increasing their time by a half. But you're not actually increasing their time by a half. You want to take off the extra half an hour that that person needed to run. So we have his time that he would run, just running the trail by himself, not even worrying about the first person, minus that extra half an hour is what's going to make us equal to the other person. Equivalently, you could put the half on the other side and make it plus a half and say that he needs an extra half an hour to match the second runner. But I like showing that minus 1/2 because you're taking it off of what the first person is done to create the second one. Multiplying everything by a common denominator, I think our quickest common denominator here is going to be 24. So everybody's going to get multiplied by 24. That leaves us with a 3x. That leaves us with a 4x and a 12. Subtracting the 4x over to the left, leaving us with x is equal to 12. We can check that pretty quickly by substituting that 12 back up in here. 12 over 8 is 1.5. 12 over 6 is 2, minus the other half takes us to 1.5, and that works. In the event that you apply this extra time fraction incorrectly, you should get an answer down here that doesn't make much sense. In fact, if you put a plus sign here by accident, you actually end up with the answer being negative, which of course is not going to work and not be representative of the situation. So before you just start assuming, oh, he's running for a half an hour longer, I'm going to add a half. Remember that you're starting under the assumption that they would finish at the same time. But in order to get them to finish at the same time, you need to take a half an hour off of the time of the second person.